So in this lesson, we're going to go back to looking at how to convert between Cartesian and modulus argument form of a complex number. This time we're going to do it in radians. Just to know that if you're going to use your calculator to calculate sine or cos or tan of an angle and you're working in radians, you will need to make sure your calculator is in radians mode. So at the minute, if you look at your Casio ClassWiz, you'll probably notice there's a small capital D at the top of the screen. That shows that you're in degrees mode. Now if you need to change that, if you press Shift and then Setup, option 2 is then angle units. So if you press 2, you're given 3 options. 1 is degrees, 2 is radians, 3 is not used on this course, it's gradians, it's often used by surveyors and things. We're only going to use the top 2 options. So if you press 2 for radians, you'll now notice that there's an R at the top of the screen. That shows that you're in radians mode. So the first example, we're going to change a complex number with a modulus of 3 and an argument of pi by 6 into Cartesian form. We're going to write it in the form a plus bi. Now we don't necessarily need to draw a diagram for this, but I think it always helps to give you an idea as to what your answer is going to look like. So I'm going to draw a diagram. So there's the real axis. There's the imaginary axis. Now if the angle is pi by 6, we need to know roughly what's that going to look like. Well, because we know that pi radians is 180 degrees, if we want pi by 6, we need to divide by 6. 180 divided by 6 is 30. So we're going to draw an angle that looks like 30 degrees. And modulus is going to be 3. So 30 degrees is this angle here. We put 3 there. That's the modulus and the argument. So we can already see, just by looking at our diagram, that the real part and the imaginary part are both going to be positive numbers because we're in the top right quadrant. So in order to change the complex number into the form that we need, we are going to use the formula that we used last lesson, z equals r bracket cos theta plus I sine theta. This is the part where it's really important that your calculator is in the correct mode, so make sure that you are in radians mode for this, otherwise you will get the wrong answer. So we know that r is 3, that's the modulus. We've then got cos pi by 6 plus I times sine pi by 6. Now we can multiply that bracket out, so we end up with 3 cos pi by 6. That is going to be the real part of our complex number, plus, and that's going to be 3 times I sine pi by 6. 3I sine pi by 6. So 3 times sine pi by 6, that's going to be the imaginary part. So you're going to need to just put that into your calculator now. So make sure you're in radians mode, type in 3 cos pi by 6. So it's a good idea to use the fraction button and the brackets on the calculator to make sure you get the right answer. You should get 3 root 3 over 2 for the real part. Plus we now need to do 3 times sine pi by 6, which is 3 over 2. So that is z written in the form a plus bi. You could change it into decimals if you wanted to, but it's often neater just to leave it as a third. So 3 root 3 over 2 plus 3 over 2i. This next example is something we've already done. We're going to convert a complex number in Cartesian form into modulus argument form. We've done that in degrees. We're now going to look at how to do it in radians. It's also worth noting that we've been asked to give the angle between 0 and 2 pi. So rather than going into negative angles, we're going to start at the real axis. I'm going to go around anti-clockwise for a full turn to get to 2 pi. So I'm going to start with a diagram. I'm going to plot 2 minus 3i on there. So 2 minus 3i. So we are going to find the modulus and the argument for that complex number. So the modulus can be found using Pythagoras' theorem, as we did in the previous lesson. So we're going to use 2 squared plus 3 squared, find the square root of that. So the modulus is root 13. Now to find the angle, if we'd been asked to find the angle between negative pi and positive pi, we would be finding this angle down here, and it would be negative because we are going clockwise. However, because we've been asked for the angle between 0 and 2 pi, we need to start at the positive real axis and go around anti-clockwise. So we're going to get a reflex angle, and that is the angle that we are looking for. Now, the easiest way to find that angle will be to find the small angle inside and then subtract that from a full turn. Now in degrees you would take it away from 360. Because we're working in radians, we're going to take it away from 2 pi. So I'm going to call the angle in there alpha again. I'm going to find alpha using trigonometry by drawing a right angle triangle on. The opposite side is here. That is 3. The adjacent side is here. That's 2. So I'm going to write tan alpha equals opposite over adjacent. So this part is exactly the same as when we've done it in degrees. So the opposite is 3, the adjacent is 2. So alpha is inverse tan of 3 over 2. Now you do need to make sure that you are in radians mode when you do this, otherwise you will get the wrong answer. So inverse tan of 3 over 2 in radians. Now the answer, the question, it asks for 3 significant figures. Because I'm going to be taking the answer away from 2 pi, I'm actually going to go to more than 3 significant figures so that I don't get any round off errors, and I'll round at the last step. So I'm going to go to 5 significant figures. 0.9827. Now remember, that is the small angle inside the triangle. We want the one in red because we need to go anti-clockwise from the real axis. So a full turn is 360 degrees or 2 pi radians. So to find theta, we need to do 2 pi minus the angle we've just found, 0.98279. Now when we find that, now the answer is actually 5.300391. We need the 3 significant figures, so I'm going to write that as 5.30. Don't forget the symbol, radians, we'll see there. So it is important that you put 5.30, not just 5.3, because that wouldn't be 3 significant figures. Okay, so we've got Z on that diagram already. They wanted Z star on the Argand diagram, the complex conjugate. Remember that Z star is just the same complex number, but with the sign of the imaginary part changed. Instead of it being 2 minus 3i, it will be 2 plus 3i. So 2 plus 3i, just a reflection in the real axis. So Z star is there. So in this example, we want to write Z in the form r cos theta plus I sin theta. Now there's a couple of reasons why it's not currently in that correct form. The first reason is that r is negative. We've got negative 2. R does need to be a positive number because it's the distance from the origin. The second reason is that there's a minus in between the cos and the sine terms. It's cos pi by 3 minus I sin pi by 3. So we also need to sort that out. So there are several ways we can do this one. I think the most logical way is to actually just sketch a diagram with the real and the imaginary axis and have a look at what we think the answer is going to look like. So firstly, I'm going to think about the angle pi by 3. So pi by 3 is 60 degrees in radians. So that's going off at this kind of angle up here. That's pi by 3. Now, first of all, if we were going to plot cos pi by 3 plus I sin pi by 3, that would just be somewhere up here. It would be across and then up. However, because the sign there is negative, because we've got cos pi by 3 minus sin pi by 3, what is actually happening to start with is if we just draw a diagram downwards, Z is actually more, well, at the minute I'm thinking sort of down here, because we've gone across and then down. Okay, we've gone cos pi by 3 to the right, and then it will be down I sin pi by 3 because of that minus. The second complication is that minus 2 is negative. So we've got a negative modulus as well. So actually, rather than being down there, z is actually going to be 180 degrees or pi radians in the opposite direction. So that is roughly where z is at this point. Okay, so this is pi by 3. This was our original guess at where z was going to be. This is kind of the second guess I had down there. But then when I realised that we had a negative modulus, I've sort of revised my idea. So now, using the opposite angles rule, this angle over here is pi by 3. So z is there. You can also double check that by multiplying this out. You're going to get minus 2 cos pi by 3 plus 2 I sine pi by 3. Now, if you calculate those two values, negative 2 cos pi by 3, that is actually going to give us an answer less than 0 if you put that into your calculator. So we know that the real part is going to be less than 0, which fits in with where I've put it on the diagram. Look at the imaginary part now here, 2i sine pi by 3. Well, 2 sine pi by 3, if you put that into a calculator, you're going to get a positive number. So that tells us that the imaginary part is going to be positive. So the top left quadrant fits both of those criteria. Real part is negative and the imaginary part is positive. So that is the place where z actually is once we've taken into account those stray negative signs there. So we now need to go about thinking, well, if this was written in a more standard way, what would r be and what would theta be in this case? So in a slightly more standard way, r, it would make more sense if we use the positive value of r. So if we let r equal 2 instead of negative 2, that's the distance from the origin. And if we were measuring this in the standard way that you would measure any complex number, you would need to start at the real axis, go around anti-clockwise. Now, because this angle here is pi by 3, and the real axis is half a turn, which is pi, so going around half a turn there. If we do pi minus pi by 3, we're left with 2 pi by 3. So that angle there where I've drawn an arrow is 2 pi by 3. So theta is going to be 2 pi by 3. So an alternative way of writing z so that it's in the form r cos theta plus I sine theta is to write 2 cos 2 pi by 3 plus I sine 2 pi by 3. Okay, so that is now in the standard form that we would normally expect. You can multiply out that using your calculator. Make sure you're in radians mode to calculate 2 cos 2 pi by 3 and 2 sine 2 pi by 3. You should get the same numbers when you actually work it out as you did with the original up here, because it is the same complex number, it's just written in a different way. So that is the answer to the question. So now please complete exercise 1E on page 18.